Hello everyone, I am Yash Sinha and today I am going to present to you on the topic Application of Finite Automata in Search Engines. This video presentation includes the following contents: Introduction, String Searching, DFA Search, Search Engine Implementation. Now I will be giving you a brief description about application of finite automata in search engine. Searching for information in the internet employs the concept of string searching. With the World Wide Web expanding with databases from diverse fields, it has become a growing concern for database curators to find an efficient searching algorithms for the task. Here we will compare brute force searching with DFA search methods. Here is an example of the string searching problem. A string searching algorithm has the task to efficiently locate the pattern within the text in minimal time with minimal usage of storage. For example, let text t is equal to this string and a pattern p is equal to this string. Over the finite alphabet, our summation is equal to a, b, c. The pattern b, a can be found in the text location 3, 5 and 10 respectively. Now, as we know that in a string searching problem, we have two algorithms. One is the DFA search algorithm and the other is the brute force search algorithm. Now, I will be going to give a brief description about the brute force search algorithm. The brute force string matching algorithm compares a pattern by symbol in each and every location of the text. If a mismatch of symbol is detected before the pattern is exhausted, then the pattern does not occur. Then matching is started all over again at the next symbol in the text and continue the same procedure. Here is the procedure for brute force algorithm in a string searching problem. If the first symbol of the pattern is same as the first symbol of the text, increment pattern and text to the next symbol of the pattern and next symbol of the text respectively and check again whether they match. Continue as long as successive increment of the pattern matches successive increment of the text until end of pattern is reached and announce match success. If the first symbol of the pattern is not same as first symbol of the text, shift pattern down text to the right by one position so that first symbol of the pattern is aligned with the symbol of the text and check again whether they match. Continue the second first method as long as subsequent shifts of pattern does not match successive increment until text is exhausted and announced match. Now in this slide, here is a brief description of the DFA string searching algorithm. A finite automata search algorithm follows certain steps such as constructing a DFA for the pattern performing the search. Each character in the text is examined just once, in sequential order when searching is done. A state transition table for the automation is created to represent the state transition function. Tell, given a text T with length n, where I represent the index of the text symbol such that I is less than 1 or greater than or equal to n, and pattern P of length m, where j represents the index of the pattern symbols such that j is less than or equal to 1 and greater than or equal to m. M less than n, where m and n are the length of the pattern and text respectively. Now here is the procedure for DFA searching algorithm. A DFA constructed for the pattern will be one state longer than the length of pattern. So the DFA takes m plus 1 states which ranges from 0 to m. Let k represent the index of states such that k is greater than or equal to 0, less than or equal to m. Initialize the start state to be 0, the final state to be m. Initialize the start and last index of text to be 1 and n respectively. Let I represent the index of text such that I is greater than or equal to 1, less than or equal to n. Initialize the start and last index of the pattern to be 1 and m respectively. Let j represent the index of pattern such that j is greater than or equal to 1 and less than or equal to m. Perform the searching. First, starting at the state k, read each text symbol against first occurrences of pattern symbol to check for match. If match, increment k to k next and read the next text symbol. The DFA will be in the kth state if ith symbols of the text have been matched with jth symbol of the pattern. Now, if the next ith text symbol matches, the corresponding jth pattern symbol. Then the automation will transit to the next kth state, that is the of the transition function k current t ith is equal to p jth is equal to k next. Otherwise, it remains in the current kth state, moves to the start state or other states not exceeding the current kth state. If all jth pattern symbols were found in sequential order in any ith location of the text, the next procedure for this is creating the transition table. Create table for all the state k greater than or equal to 0, less than or equal to m from the transition function del. Here is a string searching problem, tabular representation using the DFA searching algorithm. This is our string and we want the pattern ABA inside our text. So we start searching from the first position of the pattern, that is A. Then if it matches with the pattern, then we increment the position to B. If again it matches, then we increment to A. If again it matches, then we increment to B again. If it does not matches, then we stop there and go to our starting state K or any other state not exceeding the pattern uh, where the text has not been matched. Here is the finite automata for the string searching algorithm. Here is our text, here is our pattern, and these all are inclusive of our summation A, comma B. String matching automation, for example, pattern ABAA. We need to find this in our text, which is of the length M and pattern of length N, which is needed to be found in our text. Now here in this slide, there is a comparison for the brute force searching algorithm versus the DFA searching algorithm for the string searching. In this, the pre-processing time in the brute force searching algorithm is not available. The search time for the brute force searching algorithm is approximately of the order m, n, where m is the length of the text, n is the length of the pattern. And for the DFA, pre-processing time is of the order m, n, and the search time is similar to that of the brute force algorithm. But here in the brute force algorithm, we reach the end of the text by incrementing the counter as long as the text has been matched with the pattern. So the question arises, how did the search engine implement the finite automata application for searching engine? They do this by the process of crawling and indexing. Crawling is the process where search engines work by crawling billions of pages at a time. Indexing is the process in which search engine crawls the web using a data structure called an index, which includes all the URLs discovered by the search engine. An index includes a number of relevant key signals about the contents of each URL, such as keywords discovered and the previous user engagement of the page. Now, in this slide is a brief description of the crawling process for finding the page in a searching engine. Search engines crawl using a number of algorithms and rules DFA search included and rules to determine how frequently a page should be recrawled and how many pages on a site should be indexed. For example, a page that changes on regular basis may be crawled more frequently than one that is rarely modified on the website or web engine or the search engine, which is doing the process of searching. Crawlers by DFA search discovers new pages by re-crawling existing pages they already know about, then extracting the links to other pages to find new URLs. These new URLs are added to the crawl queue so that they can be downloaded at a later date. This crawl queue represents the first in first out algorithm. Through this process of following links, search engines are able to discover every publicly available web page on the internet which is linked from at least one other page. So now here comes the conclusion of the video presentation of how actually do the search engine implement these algorithm. The crawler ranks the documents and stores them in indexes and in the order of higher to lower ranks. In order to crawl, they use complex searches like DFA search and then places the various ranks. The complete algorithm used by any search engine is sadly unknown, but with the help of this PPT, we discovered a rough idea of how the search engine crawling method of DFA search works. So now, here is the end of our video presentation. Thank you for giving this opportunity to present this topic.